Good morning. How are you, my dears? النهاردة بإذن الله I'll talk about electric current and cell, second lesson in unit 2. In this lesson we'll talk about number 1, sources of electric current, number 2, types of electric current, number 3, the connection of electric cells to make batteries by two methods. Number 1, the sources of electric current. As you see, okay, we have two sources of electric current. Number 1, electrochemical cells, okay, like battery, like dry cell or simple cell or car battery. Okay, these cells or these electrochemical cells change chemical energy into electric energy, okay, and it produces direct electric current. Okay, number 2, second method of our second source of electric current is converting mechanical energy into electric energy, mechanical into electric. Okay, this is the electric generator or dynamo. Okay, and it produces alternating current. Okay, alternating current. We have two symbols: direct current DC, alternating current AC. Okay, now we'll talk about each of them, direct current and alternating current, and make a comparison between them. Number 1, definition of each one of them. Number 1, direct current. Direct current is the constant, it has constant intensity. Okay, direct with constant intensity. Okay, its intensity doesn't change, as you see in the graph. Okay, it has fixed or constant value. This is the intensity and this is the time. It has only one value. Okay, and it flows in only one direction. It has only one direction, like this. Okay, this is the direct current. But alternating current has variable intensity. That means it starts to increase from 0 to maximum value, then decreases into 0 again in one direction. Okay, then it increases to maximum value but in the opposite direction. Okay, then decreases into 0 and so on. So alternating current has two directions, okay, and variable intensity. Okay, this is the definition of each one of them. If we make comparison between direct current and alternating current, we start with the source of each one. Source of direct current is electrochemical cells, while the source of alternating current is electric generator or dynamo. Okay, direct current only be transmitted for short distance. Okay, we can't use direct current to operate machine or anything by using long wire. Okay, it has only short wires because it can't transfer long distance. It transferred only for short distance, while alternating current can transfer short and long, both of them. Okay, usage of direct electric current is limited. Okay, like electroplating. Okay, electroplating means covering any metallic tool with another metal. Okay, like forks, like spoons with silver or gold and so on. We have to use direct current. Okay, and operating some electric appliances, not all of them. While alternating current is used in lighting houses, streets, and operating electric appliances, most of them. Okay, we can't convert or change direct current into alternating current, while alternating current can be changed into direct current. Okay, this is the comparison between direct and alternating current. You have this table. You can try to answer it by yourself. Okay, Now we will talk about methods of connecting the electric cells in the circuit. Okay, first we have samples of electric cells. This is the electric cell. This is electric cell. Okay, this is only one cell. When we connect more than one cell together, we make a battery. Okay, so this is cell. Battery consists of more than one cell connected together. Okay, we have two methods of connection. Number one, series connection. Series. Number two, parallel connection. In series connection, we connect positive pole of the cell to negative pole of another one. This is positive pole and this is negative pole of another one. Okay, one after one. Positive, negative, positive, negative. Okay, this is series connection. Okay, or we have voltmeter. Okay, while in parallel connection, we connect all positive poles together and all negative poles together. Okay, you have to draw them with yourself, by yourself. Okay, like this. This is positive pole. Okay, and this is negative pole. We connect them like this. This is parallel connection and this is series connection. Okay, what is the difference between them? In series connection, if we have to if we try to calculate or measure the electromotive force of the battery, okay, we have here three cells. Each one of them has electromotive force. E1, for example, 1.5 volt, E2, 1.5 volt, E3, 1.5 volt. They are similar, okay? So when they are connected in series, okay, we will notice that E battery equals E1 plus E2 plus E3, or equals N times E1 or 2 or 3. Okay, this is E battery. Okay, while N is the number of similar cells. Okay, so to increase the electromotive force of the battery, we have to connect cells in series. Okay, while in parallel, if each one of them, three cells also, okay, each one of them, its electromotive force equals 1.5. Okay, E battery equals E1 only. It means electromotive force of battery equals the electromotive force of only one cell. Okay, that means electromotive force of battery equals 1.5 volts only. Okay, this is the rule of electromotive force in series. E battery equals N E. Okay, here E battery equals E one of them. Okay, this is the two methods of connection of electric cells. This is the lesson. Okay, we have examples. Okay, try to answer page 44 and I'll answer the last question, which is the problem. Here you have three similar cells, each EMF E1 equals 1.5 volt. Okay, connect them to obtain a battery. Has EMF number A 1.5 volts. Okay, in this case we have to connect all cells. Okay, that means we have to connect all cells, and the total electromotive force of them must be equals 1.5 volts. That means we have to connect all of them in parallel. Okay, like this. You have to draw it by yourself and answer many examples like this. Okay. All of them, each one has 1.5 volt. So E battery equals E1, E battery equals 1.5 volt. Okay. Number B, connect them to get 3 volts. Okay. Here, if we connect them in series, the total will be 4.5. Okay, if we connect all of them parallel, will be 1.5. So we have to connect some of them series and parallel. We will use both methods. Okay, طيب ازاي هعمل كده؟ Number one, we want to get 3 volts. Okay, 3 volts, if we divide 3 volts اللي هي مطلوبة مني. Okay, divide the electromotive force of each one cell. Okay, اللي هي 1.5. Okay, equals 2. We have to connect 2 cells in series. Okay, طيب the third one I connect it with any one of them in parallel. Okay, to cancel its value, like this. This is 1. Okay, and another one here. The total of them, the electromotive force of these 2 cells is 1.5. Okay, this is 1.5 and this is 1.5, but they are connected in parallel, so the electromotive force of both of them is 1.5. Okay, and here connect one, the rest of battery of the last one, in series, so it has only 1.5 volt. So the electromotive force of battery equals 1.5. E battery equals 1.5 plus 1.5 equals 3 volts. Okay, and number C, connect them to get 4.5 volts. Of course, 4.5 volts. This is the total number of 3 cells, and to make sure, divide 4.5 divide 1.5, the electromotive force of each cell equals 3. Okay, 3 cells. We have to connect 3 cells in series like this. Negative, positive, negative, positive, negative, positive. Okay, each one of them 1.5, 1.5, 1.5. So E battery equals NE equals 3 times 1.5 equals 4.5 volts. Okay, this is our lesson. Try to answer many questions and the problem, and ask me if you have any problems. Okay, thank you, goodbye.